people, like, what slope-intercept form? They don't know what that is, but then I say, y equals mx plus b. They're like, oh yeah, I learned y equals mx plus b. So try to learn the names of these. Y equals mx plus b is called slope-intercept form. And it should be easy to remember the name. The m is the slope, and the b is the intercept. So it's literally named after the two parts that are in it. Okay, slope-intercept form is called slope-intercept form because the two things that are part of it that make it are the slope and the y-intercept. Point slope form is the same way. The two things that make up point slope form are a point and a slope. Now, does anybody recognize this? Y sub y1 equals m times x sub x1. Does that look familiar? Okay, a couple people. All right. If you've never seen it before, I'm going to teach it. X sub 1 is the comma. Y sub 1 is a point on the line. It's any random point on the line. So in slope-intercept form, the y-intercept is a specific point on the line. In point slope form, the x sub 1, y sub 1 is any point on the line, anywhere. So nothing special about it. And then m is, of course, still slope. And that's why it's called point slope form, because those are the inputs. Then you have something called the slope formula. I'm going to write this in a different color. Slope formula is not a form of a line. It's the formula that tells you the slope when you have 2 points. We're not going to use this much today, but we will use this starting tomorrow a lot. That's the slope formula. Have you seen that before? Should have. If you have trouble remembering that one, the definition of slope is that formula. The definition of slope is change in y over change in x, right? A lot of times people say slope is rise over run. That's not a definition. That is a memorization tool that people use. But change in y over change in x is the definition of slope. It's literally what you do. When you want to find the change in two numbers, you subtract them. Or if the temperature changes from 70 to 80, you subtract them, you say change by 10. So you subtract them. So change in y over change in x. Okay, y is going to the top. Now I want to show you something that I think is really interesting. Probably maybe only 1 or 2 people will think this is interesting, but I think it's interesting, and I don't know if you ever showed this before. Okay, you don't have to write this down, you can just watch this. This is the slope formula, right? Slope formula you learned before. If you don't know the slope formula, that's the slope formula. I am going to make this a fraction, m over 1. And I'm going to cross multiply this thing. Now you don't have to write this down, okay? You don't have to bother writing it down. I'm going to cross multiply. If I multiply across, that'll give me y2 minus y1 times 1 equals m times, I'm going to multiply m times x sub 2 minus x sub 1. And then I'm going to take my eraser, and I'm going to erase the 2's, and that's point slope form. So point slope form is just the slope formula multiplied out. Pretty interesting, huh? It sure is, Mr. Pedraza. That is really interesting. Okay, so if you're watching, online, people in the class were really enthusiastic about that. Okay, so now it's just going to be practicing point slope form. Okay, and we're going to practice graphing it. We're going to practice putting things in point slope form, taking them out and putting them in slope intercept form. And this might not seem like important stuff, but when we start talking about parallel lines, perpendicular lines, and we're like, you got to put this into a certain format, we're going to use point slope form to do that. So we have to get used to using it. So this is in point slope form. The slope is just the number in front of the parentheses. You don't make that opposite. Just write exactly what you see. It says negative 1/3, so it's negative 1/3. Okay, that's easy enough. The m is right there in front of the parentheses. The point on the line is the x1, y1. So there's different ways to think about this. The number that's by the x is what's going into the x. but I'm not going to write -7 as +7. And there's different ways you can think about this. So I'm going to say this a lot of different ways. You decide which way is easiest for you. Some people say just do the opposite. You know, if it's a -7, write +7. I mean, that's fine. That's not my favorite way of doing it. Some people say it's the thing that makes that parenthesis equal 0, right? 7 minus 7 is 0. The best way to think of it is to say, you know, what would you plug into that so that it would say, oops, I highlighted the wrong thing. What would you plug into this so that it would say x minus 7, right? The minus is already there. So the x1 is the 7. You're not used to having a formula with a minus in it. So it's x minus whatever x1 is. So if I plug 7 into that, it would say x minus 7. So that x is 7. And then you guys yell out, what's the y number? 3, okay? Again, if it's a -3, you write +3. Slope here is 5. You could write 5 over 1. We're not graphing that one, so I'll just write 5. You would graph it as up 5, write 1. And again, the x number is by the x, and you do the opposite number, -2. And you could just take a second to imagine if you plug -2 into this thing, it would say x minus -2. Well, minus and negative is where you get the plus from. So again, the best way to do it is to know the form and imagine what would you have to plug into this to make it look the way it does. And then the y number is by the y. It kind of goes out of order, right? You see the 3 first, but it doesn't go first because it's a y value, and that's -3. All right. Any question about this? Okay. I am going to show you the way that I want you to graph these. And I'm going to show you another way to do these that I don't recommend, and I'll explain why I don't recommend doing it. But I'm going to tell you that a lot of people are going to do it the non-recommended way. It's not because they're intentionally doing it the non-recommended way. It's just that by the time this chapter is over, the steps that are the non-recommended way, you'll have done over and over and over again. So this is the way I want you to graph these. This is the better way. And then I'll show you the non-recommended way, and I'll try to remind you not to do that. So the best way to do this is to not multiply anything. Don't distribute. Don't get y alone. Just write the point. The x goes by the x. The y goes by the y. Or the y is the x is next to the x, and the y is next to the y in the point. Write the slope. The slope is just a fraction. And then, you know, when you're graphing, you need a starting point, right? You can't just go up 3, right 2, because you need to just go from like, where do I start that? Just remind people, this is the x-axis, this is the y-axis. This point is an xy point. So when you graph this point, you're not graphing rise over run. You're going to where x is -4, and we're going to y is -2, and you're plotting that point. Since people mess up the difference between plotting a point and slope. I had an honors pre-calculus student ask me today if the x-axis, like, does the x-axis go like this? I'm like, yeah. So I hope everybody knows what the x-axis is and which one's the y-axis. And I'm a little concerned about that pre-calculus student. There's an honor pre-calculus. They don't know the x-axis and the y-axis. It's a little concerning. This, you go up 3, right 2. Up 3, right 2. From there, and there's your line. Looks beautiful. I didn't need to do any distributive property or solving for y. I don't want you to do that. That's the better way to do the problem that I did right there. Okay, everybody go that one. All right, let's do another one. Before I do it, you write the point and you write the slope. Try to be one step ahead of me on this one. I do 3 examples like this, not because I think you need to see 3 examples, but one where I show you, one where you kind of work by yourself, and then one, you know, maybe you do completely by yourself. And if you're just like copying my writing, I mean, you're not really utilizing the notes the way I would like you to. For this slope, I think it's better to write -1/1. Not everybody listens to me, but I think it's better to write -1/1. There's a lot of people who go down 1 and then put a dot, down 1, put a dot. It's not going to work. It's down and right. So then you should have went to the point 3, 2, which is right there, right? X number, Y number, and then do the slope. Again, try to be a step ahead of me here. If your line is going uphill, you are doing it wrong. It's a negative slope. It's got to be going downhill. It's a quick check, right? This is a positive slope. Your line should be going up from left to right. This one's a negative slope. It should be going down from left to right. It's down 1, right 1. Always move right on that first point. So it's down because it's negative, and right is positive. This number is positive. And then I would reverse it and just draw more points. So just continue the trend there of the points. And in that case, I'm going up and left just to reverse the order. Are we okay with this one? Both of these problems you could get away with distributing and getting Y alone. And you'll learn that eventually. I wouldn't recommend doing it that way. Okay. You know what? To save time, I'm going to start doing this one, and you could just go ahead of me. You're going to put the point in the slope down. Do that. There's so many things that can go wrong, right? People can put it in the wrong spot. You can put it in the wrong order. People can have the wrong sign. You know, there's a lot of things that can go wrong here. Practicing it will hopefully prevent that. When you wrote down the slope, did you put the negative in the top like I said yesterday? Yeah. Good. Put the negative in the top. All right. -3, 2 is right here. You go down 1, right 2, down 1, right 2. I know I went a little fast there, but these problems shouldn't take that long. And you know, some people might say, I don't even need to bother writing this, Mr. Raz. This is just a waste of time to write this. I could do this without writing it. And all I would say to you is that you probably can do it without writing that, but since you're learning something, it's better to write it. And then when it comes to the quiz or the test, if you write the wrong thing and then if you write the right thing and then make a mistake, or if you write a wrong thing but then graph it right, I can give you partial credit. But if you have nothing written right and the line is wrong, then I have to take off all the points. So it's always a good idea to do that. Okay, now I want to show you something here. This is the way I would not recommend to do it, but this does work. And some people end up doing it this way. They just do it this way because they forget about this note. You know, a week from now they forget all about this and they end up doing what I'm about to do. So I just want to show you this. Okay, so we'll distribute this 1/2. This is not a crazy idea. It's not even a bad idea. It's just another way of doing it. You get 3/2. Then they would say, let's get Y alone. And this is because people like Y equals mx plus b. So they want to get it in Y equals mx plus b form. That's perfectly understandable. If you get this in Y equals mx plus b form, I think I made a mistake though. What did I do wrong?
How did you get the
Oh,
3, 2?
no, well, the mistake I made is this is -1/2. And then I multiplied, it's supposed to be -1/2 times 3. And, you know, 1/2 of 3 is 1.5. So you can write 1.5 or you can write -3/2, but I just did 1/2 of 3. So 1/2 of 3 you can write as -3/2, or you can write as 1.5, but that's all the same thing. I just distributed, I multiplied this 1/2 times this. Then I'm adding 2, and this is -1.5 plus 2 is 1/2. So this one, if you wanted to use Y equals mx plus b, the m would be 1/2. The b is 0.5. Let's just check that out. Here's where 0.5 is. That like it's on the line? Looks like it is. Down 1, right 2 from there is right there. So would it give you the same line? It definitely would. And that's not a bad way to check it. So if you want a way to check, that's a way to check. The problem with this way is that there's no guarantee that that's going to be a whole number. If that comes out to be 3/5, I mean, it's tough to graph. If it comes out to be 7/3, tough to graph. The other issue is that sometimes this number comes out to be a number like 10, and it's way off the graph. And so this way will work on a lot of the problems like this, but it won't work on all of them. And sometimes it'll be for a different, different reasons. So this way, you might say, I wouldn't do that. Okay, trust me, there's going to be half people in the room are going to do it that way. I can't stop people from doing it. But try to remember this way, because this is the easier way and the better way and the way we're trying to get you to do. Okay, so let's move on to number 6 here. It says write the equation of the line containing the point. They give you the point and having the slope in point-slope form. All right. In point-slope form, what you want is a point, and there's the point, and a slope, and there's the slope. So label this M and label this X sub 1 / Y sub 1. You're going to see problems tomorrow where they give you 2 points. You're going to see all different varieties of problems where you have to use point-slope form and slope-intercept form. It asks for both. Okay. If you fell asleep, wake up for this one, because this one is important to understand. All right, I'm going to rewrite point-slope form. You don't need to do this unless you want to. Okay, that's point-slope form. Okay, so when I go to do this, the y1 is 7. You guys tell me, is it y minus 7 or y plus 7? Minus, good. Okay, for the slope, it's 2. Should I write positive 2 or negative 2? Positive. Don't make that the opposite sign. And then is this one going to be x plus 3 or x minus 3? It's going to be plus. Now, let me just explain why, in case you didn't get it the first time. The formula has a minus in it. You're plugging this negative 3 into that. And now it says minus negative 3. And minus negative 3, minus a negative, always has switched to plus, and that's where a plus comes from. Okay. Now that's point-slope form, that's done. Slope-intercept form is y equals mx plus b. Okay. Do I know the m? Do I know the b? So the b's written on the paper someplace there? What do you think it is? 7? Okay. What did you think it was?
I thought it was -7, but it's 7.
All right. Well, it's not. Well, I don't know if it's -7 or not, but it's not 7. So I want to explain this to you, okay? This information is not the information that's supposed to go into this, right? The thing that goes into point or slope-intercept form is the slope and the intercept, and that's not that information. The people who do this wrong usually write the same thing. Don't write this down. This is wrong. Okay, don't write this down. It's wrong. The people who do it wrong write this. Okay, and if you thought that's what it was, that's what everybody who does it wrong writes. Like if I'm grading the test, all the wrong answers usually say that. Some say other things. Some people write IDK, or sad face. Like, oh, sad face. I don't know. But most people who do it wrong have a 7 there. Okay, so let me ask you this question. Some of you know it's not 7. You might not know what it is, but how do we know that y-intercept is definitely not 7? Do we know the reason? Right? It can't be 7. Here's your hand. Keaton, go ahead.
For the y-intercept would have to have 0 as a.
The y-intercepts are always 0 and a number. That's one of the reasons I have people write it out every time with a 0, so you get used to that. That's not a 0. That's not the y-intercept. So here's what we know so far. We know that the slope is 2, and the y-intercept is definitely not 7. Okay? Now, you wonder how do you do the problem? Well, I'm going to explain that, of course. But, people are going to get mad at me. They're like, I wrote 7 down, and he marked it wrong, and he took off all the points. That's because everybody who does it wrong writes 7. So, for me to give people all, just a -0.5 for doing that, I can't do that. I have to take off most of the points. These steps that you're about to see, we're going to do over and over again the rest of this chapter. So here's what you do. You take point-slope form. I already did this, by the way. You distribute the 2, and then you get y alone. So you distribute the number, that's the slope, and then you get y alone. It always looks the same way. Okay, distributed property, move the number away from y. Now it's in y equals mx plus b. I had no way of knowing that was going to be 13. The only other way to do this problem is to create a graph and graph it out and try to hit and see if you hit 13. I wrote 3 there. Hold on. Let's make that a 13. 13. Okay, so you can't do this without doing this first. And you take this and transform it the same way I did over here. It's the same thing I did right here. And like I said, people are going to learn this and do this over and over again. And that's why they're going to graph doing it this way. But you do need to know this, but you're not really supposed to do it on the graphing ones. Okay. So now we're just going to do 4 graphs and then answer a couple quick questions, and then we're done. So if I was doing number 6, I would use y equals mx plus b. Why don't you try to go a little bit ahead of me and graph this one? It says by the method of your choice, but like the only method that you would ever pick on number 6 is y equals mx plus b. You would never do point slope on something that's not in point slope form. I move the negative to the top of that fraction. For the b, I just highly recommend you get in the habit of writing 0, 2. If you write 2 and you do it right, I won't mark it wrong, but I would get in the habit of writing 0, 2. There's 2 2's on the graph, right? There's this 2 and there's this 2. 2, 0 and 0, 2. The first dot is always on the y-axis when you're doing y equals mx plus b. Go ahead, what's your question?
Do you always want us to write the slope and the y-intercept?
That's a good question. Like this is supposed to be a shortcut, right? So y equals mx plus b is supposed to be a shortcut. And I would say most people in this room could probably graph this without writing that. So like I wrote it down, but do you really need to write that? Probably no. On a test, a lot of times I leave blanks there. You know, I'll write like m equals and leave a blank and b equals and leave a blank. So in that case, you would have to do it. But what I'm telling you is, I think it's a good idea, even if you are like 99% sure, I would still write this down on a test or quiz, just in case you make a mistake. You have some correct work there. And then I did some extra points here. I went down and right, and then I reversed it up and left. Just have more points. You only really need 2 points, but the more the better. Later on in the year, we're going to do problems where we graph 2 lines on the same graph. They're not difficult to do. If you could do 1 line, you could do 2. But on those, we're going to have to do as many points as possible. So this problem, I would not distribute. And just take a second to think about this. If I distributed this 1/3, 5 times 1/3 is 5/3. When I move that 4 over, I would get a number that's a decimal or a fraction that's not easy to work with. And I do that intentionally because I don't want people to do that distributive property. I want people to do point slope form. So I put the x number, I get that from the near the x. The y number I get from the near the y. Those are, opposites, right? Then I plot that point 5, -4. When I go to do the slope on this one, I'm off the graph. And so you do need to know how to reverse it, right? Go up 1, right 3, you're off the graph. Reverse it down and left, down and left, down and left. So you should have an idea of reversing it. You should always check every problem. I have a negative slope, my line should be going down. This is a positive slope, the line's going up. You read it from left to right like a sentence. Is there any question about either of those? Yes. I graphed it wrong. 5. What did I do wrong? Are you sure I did it wrong? Did I do it wrong? No one in this room knows. Wait. The xy, right? x5, y4. That point's right, yes? And then up 1, right 3. I don't know if you know it. I think I did it right.
Oh, my paper system.
Wait a minute, your paper is different?
Yeah,
Mine is the same as yours.
Yeah.
mine's 4.
Oh, you're doing it online.
The
No, your paper is
PDF
the
one
exact
is
same.
No, the same. Yeah, mine's the same. Never mind.
Now the right person.
5, -4, 5. We gotta put that point down first. Okay, we got it. We got it resolved. Okay, one person's on the wrong page. Another person just made a mistake. It happens. People make mistakes. It's okay. All right. I want you to try. Well, you know what? Let's do number 8 together. Again, if you know what you're doing, go ahead of me. You know, some people may be excellent at getting Y alone, and they may have done it 100 times, and it might be like, you know, a no-brainer for them to get Y alone. There might be some people in here who, you know, it was remote learning, and they didn't understand it, and they used photo math for every single problem. They have no idea how to do this on their own. You know, so people are different, and you have to be able to do this. Whatever the X part is, this is actually not complicated, okay? So let me just kind of summarize this. If it's a positive x on 6x on this side, it's just gonna be a negative 6x on the other side. If it was a negative 6x on one side, it would be a positive 6x on the other. Just move it to the other side, okay? So that step that I do, it might look really fancy, but if you have a x on the wrong side, just move to the other side, it's the opposite sign, okay? If it's negative, make it positive. If it's positive, make it negative. So I move that over. When you divide, I don't care how your teacher showed you how to do it. This is the best way. You divide by 4 on everything, okay? Everything gets divided by 4. Then use a calculator if you're not sure, okay? Not everybody loves fractions. Not everybody's good at fractions. Negative 6 over 4, your calculator can do it. If you don't know how to make your calculator go from negative 6 over 4 to negative 3 over 2, call me over today and say, how do I do this on the calculator? And I will show you. And then 12 over 4 just is 3. Every calculator could do that. So this one would start at 3, right? B is where you begin. It's always on the y-axis. M is how you move. Down 3, right 2. Another one that goes downhill. In Algebra 1, I have to explain this over and over and over again to people. And some people just never understand it, okay? So if you're like, you know, feeling bad about the fact that this is difficult for you, you know, don't, because it's not easy for everybody, but everybody's capable of doing it. Whether you could do it or not at this moment or not is, you know, a different story, but you're all capable of doing it. All right, do 9 on your own, and then try to answer 10, and I know 11 is cut off, but try to do 9, 10, and 11 if you got it. Gotta quit. Gotta quit here. Do you have allergies or something?
Not this. From school, probably.
It's okay, you'll be okay. So the y equals mx plus b way of doing number 9, again, I'm just going to say it again. I know people are going to forget about this in a week or so, but that's the long way. It's not advised. This point slope way is better and faster. Now this one's another one. It's off the graph. You go up 4, right 3. You know, I did it on purpose because I want people to know how to reverse it. Just do the opposite. Reversing the up 4, right 3 is like making them both negative, which is the same fraction. Negative 4 over negative 3 and positive 4 over 3 are the same. So I reversed it. It's still going uphill because it's positive. positive slope should go uphill. Okay, so on this one, the slope is not weird. The slope is in front of that parenthesis, in front of the x. That's nothing unusual there. The point on this one is a little bit unusual. The x number, okay, well there's a 3 there, but you know there's nothing next to the y. So what do you think you're right on that in that situation? 0. And whenever you think it's 0 or 1, because that's what people would say, 0 or 1, is ask yourself, you know, is this the same equation, right, with a 1 there, or is this the same equation with a 0 there? You know, so ask yourself, like if I put a 0 there, y minus 0, is that y? And of course it is. So, you know, that's what you got to think of it, okay? Don't guess. Say to yourself, is that the same as minus 1, or is it the same as minus 0 or plus 1? You know, what is it the same as? The reason that you don't see any number is because it was 0. Y minus 0 is just y, and that's why it's like that. All right, I know not all of you have 11 on your paper there because it was cut off, but the slope is 6. This one, there's no number by the x, so that's a 0, and then this is the opposite of that, so it's -1. Okay.